Okay. The other question says that given that z1 is equal to 3 plus 5i, z2 is equal to this, z3 is this, and z4 is equal to 7 minus 5i. Find the modulus and argument of z1, z2 up to z4. Okay, before we solve that, let's explain something here a little. This is our imaginary part and this is our real part. Then let's say this one is any point, let's call it z. Then distance from here to here, let me make the point here. Then this theta is called argument, while the length from here to here is called modulus, and we denote it as either r, or we can denote it as absolute value of r. And this one is nothing but a Pythagoras theorem that stated that hypotenuse square is equal to adjacent square plus the opposite square. And from here we can see that our h is equal to root of adjacent square plus opposite square. So this is how we find the modulus. But since we have a point here, let's plot it on the graph before we find the solution. Okay, let me write solution here. Draw our, let's assume this is our we have from here this our imaginary part 1, 2, 3, 4, 5, 6. Okay, and from here we have 1, 2, 3, 4, 5, 6. Our negative imaginary part we have minus 1, minus 2 is 2 plus plus, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, because we have a minus 7 somewhere. Then our negative real part we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, let's start from z1. z1 says we have the real part is 3 and the imaginary part is 5. This is our point 3 and this is our point 5. Somewhere here, let's assume this is the point. Since we are not using graph, we will do it rough. Okay, distance from here to here is our modulus. Then create an angle called argument. Let's assume it's angle theta, and this is our modulus. This is our imaginary part and this is our real part. Okay, our argument is the same thing as absolute value of z, which is the same thing as root of x squared plus y squared. And from here we can see that the real part is our 3 and the imaginary part is our 5. So that from here we can write this as 3 square plus 5 square, which is the same thing as root of 9 plus 3 times 3 is 9, 5 times 5 is 25. And this is nothing but root of 34. Then our argument for our modulus for z1 is equal to root of 34, because if you add this 9 with 25 it will give us 34. And our argument is angle theta, and angle theta is the same thing as tan inverse of y over x, and this one is the same thing as, let me write it here, our argument is the same thing as tan inverse of y. Our y is 5 and our x is 3. 5 over 3 close bracket. If you point this in calculator, whatever I give you, if the angle is positive, then you will write it like that. That is this is our modulus and this is our argument. And our z2 is negative 5 plus 4. Here is our negative 5 for the real part, and the imaginary part is positive 4, which is somewhere here. Let's assume is here, since we are not using graph. We have our angle theta here, distance from here to here, which means we are looking for this distance from here to here is 5. From here to here is 4. And we are looking for our r. Then from here we can see that our r is nothing but root of negative 5 square is the same thing as 25 plus 4 square is equal to 16, which is equal to this plus this 30, this plus this 11. Therefore we have root of 41 as our modulus. And our argument, our theta is equal to tan inverse of y over x, which is the same thing as tan inverse of 4 divided by negative 5, 4 over 5. Okay, if you punch this tan inverse of negative 4 over 5 in a calculator, if it give you negative argument, then you will add 120 to it. Since we are in a second quadrant here, you will add 180 to it. Then whatever positive you get is your answer, because we know that sine, cosine, and tan, they are all period. Yes. Then our Z3. Okay. We have our Z3 is negative 2. Positive negative 2 is somewhere, real positive negative 2 is somewhere here, and negative imaginary 3, which means here and here is somewhere here, somewhere here. Then from here our argument r, our modulus r is equal to root of 2 square is 4 plus 3 times 3 is 9, which is the same thing as root of 13. And therefore our modulus is equal to root of 13, and our argument is equal to tan inverse of negative 3 divided by negative 2, which will give us 3 over 2, because the negative and negative, they will go. So if you get your argument is negative, don't forget to add 180 to it. Then whatever positive number give you is the argument of the Z3. And the last one but not the least, we have Z4. The real part is 7 and the imaginary part is negative 5. So our negative 5 is somewhere here and our positive real 7 is somewhere here. Place it here. Then don't forget our r is equal to root of x squared plus y squared, which is 7 squared, that is 7 times 7 is equal to 49, plus negative 5. Negative 5 squared is equal to 25, and this is the same thing as 40 plus 20 is equal to 60, 9 plus 5 is equal to 14. Then this one is going to give us root of 74. If you add this much to this, it will give us 74. And this root of 74 is our modulus. And our argument, theta is equal to tan inverse of negative 5 over 7. Now we are in fourth quadrant. Then you will add 360 to this. If it gives you negative theta, you will add 360 to it. Then whatever you get is our solution to this problem. Let's check the other question. Please, he who have any question, please you can drop it in the comment section so that we can attempt it together, please. Thank you.